let's discuss the Fajan's method of endpoint detection. So here also we will take the same example, sodium chloride as our analyte and silver nitrate as our titrant. Now Fajan's method is a direct way of titration where we will be using eosin as our indicator. Now here the principle underlying this kind of endpoint detection is somewhat different. I will tell you. The reaction is same. So NaCl will react with AgNO3 silver nitrate to give AgCl PPT. Now what we are doing is we are making use of the property of the colloidal precipitate. Now what is the property of colloidal precipitate? As we talked in Volhard's method, when a colloidal precipitate is present in the solution of its own ions, it tends to adsorb the ions which are in excess. So imagine the condition, actually say this is the equivalence point. Before equivalence point, chloride ions are in excess because they are analyte ions, right? And after equivalence point, obviously silver ions will be in excess which are of titrant ions, right? So what the silver chloride precipitate will do, before equivalence point, as the chloride ions are in excess, it will adsorb the chloride ions as the primary adsorption layer, and ultimately the silver ions will be adsorbed as the secondary adsorption layer. Now once the conditions move after equivalence point, what will happen is now Ag plus means silver ions are in excess as we have seen. So it will comprise the primary adsorption layer. And now there is no chloride ions left because all the chloride ions are now in the form of precipitate. The negatively charged ions are nitrate ions, right? So nitrate ions actually should comprise the secondary adsorption layer. But there is presence of eosin. So this is the sodium salt of eosin and they are negatively charged. So instead of nitrate ions, the indicator ions will start to adsorb as a secondary adsorption layer. Now once they come in contact with the silver ions, which was the primary adsorption layer, the silver ions and indicator ions, they form a pink colored complex. They give the precipitate the pink color, and that pink color indicates the completion of reaction. So here we are taking in consideration the property of a colloidal PPT to adsorb its own ions which are in excess. Now here we have to consider a few points. The indicator which we are going to add should be oppositely charged to the one which will be adsorbed after equivalence point. So after equivalence point, titrate is going to be in excess. So Ag plus will comprise the primary adsorption layer. So indicator has to be negatively charged. So we are going to use that kind of indicators for this type of titration. Next, some factors affect the choice of indicators and altogether the endpoint detection by Fajan's method. First, what is the surface area of the precipitant? What is the intensity of color formed after the equivalence point? It actually governs the choice of indicator also. So these factors should be taken into consideration before choosing the right indicator for this type of titration. Another alternative theory is that once the charge on the adsorption layer, primary adsorption layer, shifts from negative to positive, there are some structural changes going on and that leads to the different color formation. But I think this theory is good enough to explain the color change, that the indicator and the primary adsorption layer, they give a different color, and then we can actually see that the color is changing, means the endpoint is reached. So this is how the Fajan's method works.